All right, this is a fun one here, I guess. I get a lot of questions from it. We're getting quite a few. So let's just make a quick video on it. So we have to think about a couple things. What is the rate and what is the starting point in this scenario? So it says that they're starting with 200 liters and they're burning fuel at a rate of 1.5 liters per kilometer traveled. So our variables, well, the independent variable, that's the input, that's the distance traveled. So that's the distance in km, right? And the dependent variable, that would be the remaining fuel, right? Which is was measured in D. So the function, the remaining fuel, is equal to negative 1.5 D. So it's decreasing, right? That's the key here, is that we're burning fuel. It's decreasing by a rate of 1.5 liters per kilometer. And we start with 200 liters, okay? So I just made a scale here for the dependent variable. And so the independent variable, another thing is I need to think about how far it's going to go before it runs out of fuel. Let's see, let's say this is 20, 40, 60, 80, 100, 120, 140, okay? So we're starting at 200 liters and we're decreasing by a rate here, okay? Now before I make my graph, I want to think, I could go rise over run here. So, and it said you could use this where you got a, for every 10 kilometers, we decrease by 15. I would like to go 40 kilometers and it would decrease by 60 because that might be a little bit easier. Because that would be what? That would be here at 140. So something like that there, I guess. Is that right? All right, let's just wait. So then let's look at the next question before I make my graph. How many kilometers can we go before we run out of fuel? Well, if we run out of fuel, first of all, we need to find out what the input is. What is D? We're trying to find out what D is here. The output we know is going to be 0. Okay, I can use this function here. So let's just put that here. Our output is 0, negative 1.5 D plus 200. Okay. So 1.5 D is equal to 200, and then I undo the multiplication by dividing, so D is, well, let's just say approximately 133 liters. Okay, so if I use my calculator for that. Where is that? Okay, so here's 130, so maybe somewhere around here. That might be a good place to actually draw my line, so I'm just going to insert a line here. Now I don't need to have arrows on this because once I run out of fuel, I'm not going to go any further, and I'm not going to go less than 0 distance. So this is just a segment here, this linear function. All right. Next question: what does the y-intercept represent, and what does the x-intercept represent? So let's think about, well, the y-intercept is more obvious. Because that's always our starting point. That represents, so that represents the 200 liters of fuel that is in the tank when we started, okay? So this is the fuel in the tank. That's our y-intercept at the start point at 0 kilometers. The x-intercept, well, what do we notice here? Here, that's when, that's basically how far we can go before we run out of fuel. So this is where we have 0 fuel. And then we can see here it's 133 kilometers. How would the function and graph change if the truck started at a different amount of fuel? What if we started at, say, 240, okay, right here? Well, if we did that, we'd probably see that the only difference would be the rate should probably be the same, but we would see a different starting point. Or maybe we have even more fuel, or we could have less fuel. All of those, see how these lines are parallel? Because they have the same rate of change, would still be burning fuel at the same rate. How would the function or graph change if we used more or less fuel? Okay, so let's say that we took a lot of weight off, or we dropped a load off, and then so it burns a lot less fuel. Okay, but we still have that same starting amount, so we're going to probably see we could go further distance with an empty truck, because trucks are heavy. What if we had a heavier load? We might burn more fuel. We might see it steeper. So the rate of which the truck burns might increase or decrease if we change that rate, and then it may depend on how much weight. But our starting point we'd still say is 200. Okay, so the big ideas here are this slope represents the rate. Our starting point is the y-intercept. That's how much fuel we have. And this is the relationship between the distance we travel and the amount of fuel that we have in the tank. Okay.